Hello everyone. Today our team is excited to present the midterm demo of our project Satellite AI. In today's presentation, we will briefly introduce the background of our project, what Satellite AI is, and what problem it solves, and what we aim to provide to our users. Then we will explain how we organize our teamwork using an agile workflow. After that, we will showcase the key features we have already completed. And finally, we will share our future plans. So let's get started. Satellite AI is a fintech and proptech platform built for first home buyers and new migrants in Australia. Buying a property can feel overwhelming with information scattered everywhere, suburbs hard to evaluate, affordability unclear, and policies full of jargon. So Satellite AI solves this by bringing everything into one platform: property insights, financial tools, and AI-powered guidance. So all simplified and visualized so users can make confident property decisions. In terms of our team, our tutor is Winston, and we currently have 9 developers working closely with the DevOps team and the business analyst to deliver the project. In our project, we follow an agile methodology with 1-week sprint. This allows us to work iteratively, adapt quickly, and keep everyone aligned. For sprint tracking, we use GitHub projects where our team members customize a Kanban board that functions very much like Jira. This helps us visualize tasks and progress clearly. We hold daily stand-ups on Gather, which ensures that the team stays connected and aligned even when we are working remotely. All of our documentation are stored in Notion, so any team members can easily refer back to important information. We also maintain an Excel-based team dashboard. This makes sure that even if someone cannot attend a meeting, they can still keep track of decisions, progress, and updates. Finally, we emphasize open communication. Team members are encouraged to raise blockers and share progress in real time, which helps us resolve issues quickly and keep the project moving forward. Now let's move on to the feature highlights of our project. We've completed several important parts of Satellite AI, including back-end work such as the property model and similar property suggestion in the property report page, the check suburb snapshot service, and the stamp duty calculator API for the loan calculator. But today we will focus on 4 highlights that best represent our progress so far. These include a homepage search function with fuzzy matching and a suggestion bar, a suburb report page that displays key metrics and insights, user registration and login flows to support authentication, and the initial setup of our AI architecture, which is built on a multi-agent design. To start with, I'd like to hand it over to Carlos, who will introduce our homepage search functionality in more detail.
All right, thank you, Nathan. So for the homepage, this is the entrance of our project. So as you can see, we have created a search bar that helps the user to search for info regarding like suburb or property in our platform. So we have implemented an autocomplete approach, meaning that the user does not need to input the full query. Instead, they only need to input a few characters, then that can trigger the backend call. As long as the query length is equal more than 3, then the call will be triggered. The reason we picked the number of 3 is because most of the short form of the state here in Australia is consist of 3 characters. For example, like New South Wales, its short form is NSW. For Victoria, its short form is VIC. And that's why we set the condition to be query length of 3. So after the backend call is triggered, then you will pass to the backend to do some model validation. Afterward, we do the data search in the database. So this query will try to merge 4 different problems in 2 tables. The prompts include the suburb name, the state name, the state code, and the properties. The tables include the suburb table, and the property table. So once the search is done, all the results will combine and export return in the type of a DTO, so that only the selected info will be shown to the front end. This prevents the leakage of sensitive info in our database. So once the data is returned to the front end, it will be shown as a format of list. The user can simply scroll up and scroll down to see the return data and select that option or the area that they're interested in. After selecting the option, they can simply click the Get My Report button. Then they can navigate to the suburb report page. So next, we will demonstrate how everything works together.
Hi everyone, this is the homepage of our project. As you can see, it's still in progress, but we want to demonstrate how can the user search for certain suburb or address info through our platform. We are using auto-complete approach, meaning that the user only need to input partial query, and that will trigger a backend call and in turn do the data matching in the database to finish the searching. For example, let's say I am interested in New South Wales, so I input an aspect. So when the query length is equal or more than 3, then that will fulfill the condition and trigger the backend call. So the database will return all the matching data to the front end, and those results are exactly what we are looking at right now. So let's say I'm interested in Wollongong. When I click this option, this single piece of info is stored as a state in the front end. It will also be used as a parameter in the future when we try to navigate into different pages. For example, when I click the button Get My Report, well, so here we are in the suburb report page for Wollongong. And these are all different info about Wollongong. Let's say the median rent, the median price, rental yield, etc. So that's all for me.
Thanks, Carlos. Users have multiple ways to enter the suburb report page. As the demo video shows, one of the most common paths is by searching a suburb on the homepage. After search, the system retrieves relevant data from our backend database and presents it clearly on the report page. The suburb report page displays several key data sets that we carefully selected as the most important indicators for evaluating a suburb. To make the information easier to interpret, we added data visualization. For example, metrics such as rent growth, price growth, and population growth rate are highlighted in green or red, giving users instant clarity on whether the trend is positive or negative. We also included information icons next to the data. When users hover, they can see short explanations of what each metric means. Looking ahead, our AI will be able to provide contextual explanations of these numbers. And as you can see from the screenshot on the slide, the page is fully responsive. On a mobile screen, the layout automatically adapts, ensuring users still have a clean and accessible experience no matter what device they are using. Overall, the suburb report page helps users evaluate suburbs more easily and make confident property decisions. So next, let's talk about user registration and login. In Satellite AI, we've implemented a secure registration and login flow to support authentication. This is essential because some of our features are only available to login users. To give you a closer look at how this works, I will now hand it over to Barry, who will walk us through the user registration and login process in detail.
Okay, thanks, Levin. So for this part, I will introduce what we have implemented for the registration and the login pages. Here we provide a summary of features from our registration and the login pages. For example, in our registration page, we have user input validation and the password strength suggestion feature. And we use email verification code to activate user account and complete a user registration. And we also use the password encryption to protect users' information. For login page, we provide password visibility button to improve user experience, and we use a JWT token for authentication, and we also implement brute force attempt protection to protect our website. And both pages are designed with a responsive layout for improving user experience. And I will introduce more details about these features in the following slides. So first of all, for the user registration part, our registration form will check users' input. For example, if user input invalid email format or user missed some block, they will get some error information about their input. According to this error information, user can easily input their information correctly. And next, we provide a password strength suggestion feature, as shown in the second figure. And we will suggest user to use a stronger password, for example, using the special characters, using uppercase or lowercase letters to ensure information security. And another highlight feature is that we implement the email code verification feature by using MindKate. After user input the valid information and click the create account button, they will receive a verification code via their email, and they need to input the correct verification code to activate this account and finish the entire registration process. And during this process, we will check if this verification code is expired or is incorrect. And in our database, we will store the user's information, including the username, email address, password after encrypted, and also the account status, for example, whether this account has been activated. And in next slide, I will introduce our login page. In our login page, we will also check the user's input, like if the email format is correct or if the password has been filled here. And also, to improve the user experience, we'll add a password visibility button here. So user can check their password input after click this button. To prevent the brute force attempts, we implement a brute force protection by using a limit return middleware. If the same IP address attempts to log in five times within 15 minutes, we will block this IP from further login attempts and require another 15-minute wait. When user input the correct email address and password, that means they successfully log in their account. The JWT token will be generated by the backend, and we will store their username and the JW token into local storage, and also store the useful information into the Redux. The information in the Redux can be used for the other pages. In future work, we will also use the Auth0 and the double token strategy to improve the security and the user experience. And in next section, I will show a quick demo for the registration and the login process.
Now we are at the registration page. Firstly, we just quickly input the correct username, email address, and password. And you can see here, we will show the password strength and suggest user to use stronger password. Let me input some password.
And after we click the Create button, the user information from the input will be stored into our database. And here, this account is not activated, but we will also store this inactivated status in our database. And to activate this account, we need to use the verification code, which will be sent to user's email. And here I have got the code, and now we use the code to activate this account. Okay, so now we activate this account and we finish the registration process and jump to the login page. In login page, we just input the correct email address and the correct password. And we have this button. You can see what password you input here. And we click login button. In our backend, we will check the email address, the password, and also the account status. And if all of these are correct, we will jump to our homepage. And if there are something wrong, for example, the incorrect password or the account has not been activated, we will provide generic feedback. Okay, that's all for the registration and the login process.
Thank you, Barry. So we've designed the AI architecture as shown in this picture. Our idea is to build an AI chatbot that acts like a consultant for the home buying journey. This chatbot can guide users step by step through the process, from choosing a suburb to check affordability to understanding policies. At the same time, users can ask questions at any point. For example, what does LVR mean? Or how is this suburb's rental yield? The chatbot answers in plain language and help users make sense of complex financial and property data. To support this, we designed a multi-agent architecture. Instead of relying on one model to do everything, we have specialist agents, including a real estate agent for suburb and property data, a mortgage agent for affordability and repayment scenarios, a knowledge agent using RAG to retrieve internal policies and documents, and a web research agent for external updates. And the orchestrator agent routes tasks to the right specialist. Together, this framework allows the chatbot to act not just as a Q&A tool, but as a decision support assistant that's interactive, trustworthy, and easy to use. And beyond the chatbot, this design makes our AI model and extensible. In the future, if we want to add, for example, a taxation agent or an insurance agent, we can simply plug it into the system. Looking ahead, our future plans include several important developments. We will continue developing the property report page by adding detailed property level data, giving user a much deeper view of individual properties and building a loan calculator that can simulate the repayments and the different interest rates and compare loan options. Another key step will be adding a superannuation module, which allows users to explore how their superannuation could potentially support home buying. To make these features more intelligent, we plan to assign each of our team members to develop one AI agent. Each agent will focus on a specific area, such as property data, loans, or policies. So our AI framework grows together with our feature development. In addition, we will expand our platform functionality to let users explore suburbs more deeply and smartly manage their favorites page, making the experience more personalized and interactive. Altogether, these plans will help us move Settler AI toward becoming a comprehensive decision support platform for first home buyers and new migrants. And for the last part of our demo, we will now hand it over to our DevOps team. They will showcase some of the important work they have been doing to support the project.
Hello, everyone. Can everyone hear me well? I guess it's all right. I'm Eric. I'm excited to share what our DevOps teams has built for Settler AI. In the past months, we have created a robust, scalable infrastructure that's ready to support Settler AI's growth, thanks to the cooperation and the support from our dev team and our tutor. First, let me walk you through our architecture. We have designed a multi-tier system that prioritizes security, scalability, and reliability. We have a front-end and CDN layer, and also we have our application layer and database layer. In our front-end layer, users access Settler AI through CloudFront, our global CDN, which serves our S3 hosted static website with lightning fast performance worldwide. Secondly, we have our application layer. Behind the application load balancer, we are running EC2 instances in a private subnet within our custom VPC. This ensures our application servers are protected while maintaining high availability. Thirdly, we have our database layer. Our data lives securely in the RDS instances, connected through private networking, ensuring data integrity and performances. We might adjust our architecture in the future to provide a better performance. Next page, please. Ooh. Thank you. Now I'm going deep on our chart of our design. What makes this special or makes any project special with DevOps team is our end-to-end automation. First, we have our robust CI/CD pipeline. GitHub Actions orchestrates our entire development workflow, from code commits to Terraform infrastructure provisioning, then to the production deployment. Our containerization strategy centers an automated Docker image creation through GitHub Actions. Every code commit triggers our build pipeline, which compiles the application, creates optimized Docker images with proper tagging strategies, and pushes them to our private ECR repositories. Also comes next is infrastructure as code with Terraform. Every AWS resources you see is defined in Terraform modules, version controlled and automatically deployed. This means consistent environments, rapid disaster recovery, and infrastructure changes that go through the same review process as our application code. The last one is our database architecture. Our RDS instances runs in a private subnet with automated backups and many more features. This infrastructure delivers real DevOps value. Automated deployments means faster feature delivery. Terraform managed infrastructure ensures consistency and repeatability. Database resilience ensures data protection, and our CI/CD pipeline catches issues before they reach production. We have reduced deployment time from hours to minutes while improving reliability. Our monitoring and logging setup provides, in the future, our monitoring and logging setup will provide visibility into application performance and database health, so on and so forth. We are proud of what we have built and what we have worked together in Settler AI. The infrastructure is live, tested, and ready to power as of now, but in the future, we will bring in more features into this project. Thank you.
That's all from us for today, and thank you, everyone.